All right, so these are your types of chemical reactions. Your chemical reactions are basically you can look at what your reactants are, and also helps you predict products. Or if you have the products, you can figure out what type of chemical reaction that you have as well. So if you have an element plus an element, or a compound plus an element, but you have two different things, two different reactants, and they come together to make one product, so you have less products than reactants. This is called a synthesis or a combination. Okay, this is a synthesis or a combination reaction. Now, by contrast, if you have more products than reactants, so let's say you had compound, so this is bonded together, right? This is compound AB, put lines in between the ones to indicate bonds. You have compound AB, and it breaks down into the separate parts A plus B. Now this may be two elements, it may be an element and a smaller compound, but the point is I have more products than reactants. When that happens, this is called a decomposition. So this will be a decomp. So what's the key here? I have more reactants than products, synthesis, right? I'm putting things together to make something. Here, I'm breaking something down, so I'm going to have more product than reactant. Now, the next thing is, the next one I have is, look at it. I have a single element and I have a compound. Single element and a compound. So this is element A, compound BC, okay? And what I end up with is element B and then compound AC. So what happened? Well, A and B changed places, or A replaced B. Now, of course, you know, when you have your activity series, not every element can replace another element in a chemical reaction because it's based on attraction and things like that. But, you know, ideal world, this is called a single replacement or single displacement. Okay, a single replacement or a single displacement reaction. This is kind of like you showed up at a party with one friend and left with a different friend. Okay, so something changed places, but the thing you have to make sure of is like replaces like. So a cation can replace a cation, and an anion can replace an anion, but a cation cannot replace an anion. So they have to be of the same nature. If it's a positively charged ion, it can replace another positively charged ion. Negative can replace negative, but a negative cannot replace a positive. Because remember, when you're bonding, these things are bonding together in an ionic compound, you're going to have a cation and an anion to make them neutral. So you can't have two positives or two negatives together. Like charges repel, okay? Opposites attract. Now here, similar to a single replacement, you have a double replacement. So basically, they switched partners. So if I have compound AB that's reacting with compound CD, then they switch partners. So now A's with D and now C's with B. But again, cations are written first. So in this case, my A and my C are my cations, and my B and my D are anions. So I have to make sure to keep that order as well. Cations come first in an ionic compound. The next type of reaction is easy to recognize. This is what we call a combustion. And a combustion is when I have an organic compound. Now, organic compounds are compounds that contain carbon and hydrogen. Now, it could just be carbon and hydrogen. It could also be carbon, hydrogen, and oxygen in this organic compound. But I'm going to have an organic compound, and that organic compound is going to react with oxygen. And the products, when an organic compound reacts with oxygen, is carbon dioxide and water. The most common example that you've seen 1,000 times before is cellular respiration. C6H12O6 reacting. That glucose, that sugar molecule reacting with oxygen to produce carbon dioxide and water. This could be methane. It could be CH4. It could be ethane. It could be some other organic compound. But the thing is that you have an organic compound that reacts with oxygen to produce carbon dioxide and water. I'm going to go and do one of these. I'm doing this at the end of balancing, because the key to balancing these organic compounds is to balance carbons first, hydrogen second, and oxygens last. So I'll do a couple examples of that because I left it off of the other video. The next one is an acid-base neutralization, and this is a special type of double displacement reaction where one of your reactants is an acid, the other one is a base. So if I had something like, say for instance, phosphoric acid, and it was reacting with sodium hydroxide. So I have an acid, starts with the hydrogen, and a base has the hydroxide. Again, remember we talked about with balancing, that hydrogen and that hydroxide is going to come together. One of my products is going to be water, and the other one is going to be a salt. And that salt, in this case, is going to be sodium phosphate, because PO4. The sodium is going to react with the phosphate. All right, so that's an acid base. So the way you recognize acid base is one of them starts with hydrogen, the other one has hydroxide. One of my products is going to be water. Organic compounds with combustion, organic with the oxygen, you're going to get carbon dioxide and water. And I'm just going over the basic types of reactions. If you need another type, just let me know, because there are some others that you might be looking at as well. Single and double displacement. Single, you're usually going to have an element with the compound, gives a different element in the compound. Double displacement or double replacement, two compound swap. Remember, your acid-base neutralization is a special type of double displacement where you have an acid in the base, and so it's going to neutralize and create that water. Decomposition, I have more product than reactant. Synthesis, I have more reactant than product. All right, toodles. I'm gonna come back with that organic one real quick.